Okay, now that we've had the live stream set up, we'll go ahead and get started. Welcome and thank you for tuning in to today's Erie Hack Cleveland Quarterfinals hosted by Cleveland Water Alliance. Now that we've had the live stream set, my bad. Okay. We are excited to hear from 8 regional teams and learn about their ideas to innovate the lake. Each team will be limited to 5 minutes to pitch their idea or innovation, followed by a few minutes of Q&A from our judges. After we hear from all of the teams, the judges will deliberate privately to determine tonight's winners that will be advancing to the semifinals on November 4th. We've got a great panel of local judges with a wide range of expertise, and I will introduce them in just a moment. But first, I'll turn it over to Cleveland Water Alliance's president and executive director, Brian Stubbs, to kick us off with some remarks.
Thank you, Felicia, and just welcome. Thinking back 2+ years ago on our last Erie Hack and everything that our world has been through, I wasn't sure if we were even going to be able to do Erie Hack in the middle of a pandemic, but we managed to use technology and figure this out. So speaking both for myself and our board of directors, we're just beyond happy that this is continuing every other year, and just thank you all for participating and joining us today. We're thrilled to have you, as I mentioned, the 3rd iteration, and I just hope everybody has a lot of fun today. I always say this is the start of a journey, no matter how today goes. As many of you are aware, Erie Hack is not your typical hackathon. It's multi-month, multi-city competition. We've awarded over $250,000 to date directly to innovators and entrepreneurs such as yourselves. And we're looking forward to awarding more prize dollars and support services with this year's competition. This unique event would not be possible without our new and returning Erie Hack organizing partners in Detroit and Windsor, Toledo, and Buffalo. Thank you to TechTown in Detroit, and special shout out to Paul Reiser, the WEtech Alliance in Windsor, Midstory in Toledo, and Ryan and the Sustainability Office and the team at the University at Buffalo, Blackstone LaunchPad. We know that collaboration is key and that we're stronger when we work together to solve our Great Lakes' greatest challenges. We're all in, as we say in Cleveland. We're also grateful for our Erie Hack funders and champions. This year's event is presented by the First Solar Community Giving Fund of the Greater Toledo Community Foundation and the Northeast Ohio Regional Sewer District, and supported by OHM Advisors and the Cleveland Metro Parks. And we just thank you for all of your continued support, and a special shout out to the First Solar company and their foundation in Toledo. It was just really nice to have them come in this year, and we really support what they do for our economy and driving us towards a clean economy. So needless to say, things do indeed look different this year. As we say at the Cleveland Water Alliance, our challenges are our opportunities. While competing in a virtual space may limit our face-to-face interactions, it also allows us to expand our imprint beyond participating Lake Erie cities, extending an invitation to innovators everywhere. After all, Lake Erie's challenges are not unique to us. We're seeing water issues on the rise globally with droughts and shortages, inclement weather, and the climate crisis, the detrimental impact of harmful algal blooms and emerging contaminants like PFAS and PFOS, aging infrastructure, and continued issues of equity and access. You all have the opportunity to not only make an impact locally, but also hold the potential to have your ideas and innovations make waves globally. We're uniquely positioned to utilize our Great Lakes to innovate, invest in, and elevate technologies that will conserve the vitality of Lake Erie and beyond. Exciting investments, opportunities, innovations, and collaborations are on the horizon for Lake Erie and for all of you here today. Thank you for seeing the value of our lake, that it's worth our time, our resources, and our investment to build sustainable, equitable, thriving ecosystems and communities around the Lake Erie Basin. At this time, again, thank you, and I'm going to go pass the virtual mic back to Felicia so we can get started. Good luck, everyone. Felicia.
Thanks for that, Brian. Now I'm going to introduce our esteemed judges. If you could please turn on your cameras and be recognized. Dr. Scott Hardy, Extension Educator with the Ohio Sea Grant College Program here in Cleveland. Ruben Cortez, Director of Sensor Development at Xylem Innovation Labs. Donna Friedman, Watershed Team Leader at Northeast Ohio Regional Sewer District. And last, but certainly not least, Ebony Hood, Community Relations Specialist at Northeast Ohio Regional Sewer District. Thank you all for your contributions to Erie Hack 2021, which wouldn't be possible without you. Without further ado, it's time to introduce our first pitch team, Island Hoppers. Mike, please turn on your camera as you've already done, and you can share your screen at this time. I'm going to put 5 minutes on our timer, and once we're all set, I will cue you to begin your pitch.
Mike, I think you're on mute.
The timer is entering the Zoom meeting, and we'll be ready in momentarily. Okay, it has telling me that it can't. Okay, so what I'm going to do instead is count down in the chat starting from 2 minutes. And so just watch out for
I'll
chat.
set a timer here on my end to make sure
Okay.
we be a little better for me.
Thank you. I'll get it started whenever you're ready.
Okay, I'm good to go.
Awesome.
Shall we?
Mhm.
All right. With 5 minutes, let me go quickly through. My PowerPoint is not going down. Here we go. Okay, I want to talk today about lacing a green ribbon up the rivers of Lake Erie and the Great Lakes, a series of islands to let animals go back and forth between the lake and the promised land of the parks. My background, I should say, I'm a mechanical engineer, University of Akron. I also have an MBA from Baldwin Wallace College. My career has been product development focused. So the hack that we're attacking, the jumping off point, is community water resources, bringing social awareness and surface quality awareness, restoring natural filters and habitat. Everything's gonna be Cleveland based, that's where I am. And here's an example of the Cuyahoga River. We have the Dorothy Ann Pathfinder. It's a 700-foot long freighter, 70 feet wide. It displaces 27,000 tons. That goes up and down the river 400 or 500 times a year. You can imagine the forces that are developed to move that much of a boat up and down the river. It creates a very difficult situation for life to really grab hold along the sides, not to mention it's lined with sheet pile. So we would like to change this. Not be the first, but hopefully we're the last. The green bulkhead. The river really dictates the opportunities on this. The Cleveland Metro Parks has had great success working on the land side of the river, cutting back some of the pile, letting the river overflow and creating wetlands there. Unfortunately, there's not land available on the whole length of the river to do that. So other attempts have been made with varying degrees of success, hanging baskets, floating islands, different types of mats that float. All good attempts, can learn from all of them, but none of them have been sustainable. The fluctuating water levels with the constant flow of the river, the shipping traffic, limited space, crush potential on all those islands, the thrusters that we talked about on the freighters to move those things, they're generating that force backwards to move those. The waves, the reflection off the walls, there's nothing there to dampen them. Silt loads, ice coming down the river. It's a very challenging situation to do, but very critical to accomplish. Our solution is this basket. This basket is unique in that it's designed from recycled fire hose. It will be put together with stainless steel hardware. The fire hose, double jacketed, will allow us to fill it with buoyant material. Closed cell backer rod is what we'll start with. So we can adjust the buoyancy, whatever's needed for the specific river goals. We can adjust the weave for the plants that go through it. It has a very, very low center of gravity, so it will ride out those waves. It's linkable to bake more. It's crushable and will come back. It's unsinkable. It's very valuable. How valuable? One island, 24 inches in length, 18 inches wide, 12 inches deep, can develop over 100 cubic feet of new habitat on the river. Link those together and something special becomes. The good targets to start with these, to get that ribbon of green up the river, the mouth of the river, we can reach the most people there, most fish to attract, most shipping, narrow river channels where they could be crushed, heavily shipped turns to dampen the bow thrusters, flatten out the waves. And what we really want to do is replace all those tires that are hanging off the sheet pile. It's a very, very visible educational outreach tool. Imagine these as you go down the east bank of the Flats Boardwalk, or you see them at the Nautica Music Center out in front there, or any of the parks along the river. Just simple signage. I know a lot of the Erie Hack focuses on farm runoff, but you know what? I live in a neighborhood, every single lawn is super green. There is a tremendous amount of fertilizer there. If we could just tell those people that are walking around there to cut back on their fertilizer, when to put it out, when's the right time, that will make a big impact on itself. We're providing new to the world habitat that will filter, fits where other systems won't. Like we said before, it's very scalable. It's very adaptable to the goals of any river by adjusting its buoyancy or the weave of the basket. Very, very limited capital investment to get going. Recycled materials, minimal maintenance once established, and very, very quick to implement. That's one of the best things about this one. You would see this very quick. People would see this very, very quickly because it's not a project that's going to require a tremendous amount of work up front. It's a good tool in the box, coupled with the metro parks, to get a green ribbon up the river. Thank you.
Thank you. Timing was perfect. If judges could turn on their cameras and unmute their mics and start asking questions.
I can go first, if that's okay. Hi, Mike. Thanks for your presentation. Really appreciate it. Having worked on a couple of those aforementioned projects along the bulkhead on those green projects, I noticed you said that you think it'll be minimal maintenance. One issue with keeping material on and in those older first attempts, I guess I would say, is keeping material in the baskets themselves and on these islands rather than them washing out, especially when you have those big waves from the ships bumping into them. What's your plan for maintenance, and how do you expect to keep material in those baskets?
Twofold. One, the weave of the basket, we can adjust that to be as tight or as loose as possible. That I think that would be dependent on what the river system wants to get planted and moving. We can put those in, the baskets can be grown out and then moved into those heavy areas. So there's a good root system in place already holding it. And additionally, we don't have to just put in dirt. We can put other binding materials in there as well and bring some of that other existing technology out there joined with this to help it be successful.
Thanks. And I have one more question. Do you have like the rough cost for one basket to be made, what that would be?
I just priced out material off of that drawing. So that size, which is about a 15-gallon container, roughly like a large Sterilite container, is going to be about $170 in material.
Thanks, Mike.
We have time for one more question.
I actually got a question for you, Mike. Two parts. One, how are you going to fasten these suckers to the bulkheads? And two, you said each basket would equate to roughly 100 square feet of habitat or 100 feet of habitat per basket. How are you coming up with that math?
Okay, so the first one, how to fasten it. I think the sky's the limit there, really. In the past, they've been done with chains, but that's going to be site specific, you know, whether they're staked, whether they're chained, whether they're anchored to the bottom. I think depending on the specific location, you look at the different options. You can even go as far as to possibly weld some studs onto the break wall, or you could bolt it to the extreme, or at the onset, I really envision them just hanging. Now, the other question was, how was the 100 cubic feet generated? 24 inches in length, 18 inches wide, and 12 inches deep. And if you assume around the perimeter of that, you get 18 inches out, with depending on the plants, say they're laying over leaves or whatever coming out from the basket, 18 inches. And if you assume that the root stock would grow down and develop roughly a 3-foot depth underneath that area of habitat, and then above that, assuming that it grows about 3 feet tall, you would have, pollinator habitat and whatnot.
Okay, thank you.
All right, thank you. Next up, we have Earthen Made. And remember to turn on your cameras, share your screens, and hit the present button. Judges, if you could please turn off your mic and your videos. And I have my timer back. And so once you start speaking, I will start the timer.
All right, trying to figure out how to share screen in this. Oh, there it is. Hello, everyone. My name is Andrew Needs, and I'm the project lead for Team Earthen Made. In recent years, the impact of climate change has led to an increase in coastline erosion and a significant loss of shoreline and coastal infrastructure. Every year, $500 million of shoreline and coastal infrastructure is lost due to shoreline erosion, with $150 million being spent on projects such as beach nourishment and other erosion control measures. Current erosion control products work, but all have issues. These include significant cost or difficulty in obtaining them. Also, they are not environmentally friendly due to the large carbon footprint created during the production and transportation. Shoreliner is a manufactured artificial stone with both the physical and aesthetic attributes of natural limestone. The cost of shoreliner is 50% of the cost of the most commonly used coastline erosion technology. The appearance of shoreliner will closely resemble that of natural limestone, but can also be augmented to have other unique textures and colors. Benefits of shoreliner include the significant reduction in product cost, as well as the ability for the material to be produced in proximity of the project. Shoreliner utilizes beneficial waste material as a primary component of the mixture. This adds to the lower cost, as well as significantly reducing the carbon emissions due to the product manufacturing. Our target market will be the Great Lakes region of the US, which encompasses 4,800 miles of coastline and 33 million individuals. The initial market for Earthen Made will consist of the Ohio coastline along Lake Erie. This includes a total of 352 miles of shoreline, of which 157 miles is considered by the Ohio Department of Natural Resources to be rapidly eroding. When considering the cost of protecting the shoreline using traditional material, the market value for this region would be worth $785 million. Competitors to shoreline include products such as geotextile tubing, concrete bin blocks, precast dolos, and naturally quarried stone. The drawback to using these products is that most have an unnatural and unappealing look, while all cost more and increase greenhouse gas emissions. While they may fix the issue, these coastline protection measures also add to the problem they're trying to resolve. In recent years, the number of erosion control projects has increased significantly and continues to rise. One such example of this is the Shoreby Club barrier wall, which is in Brentnall, Ohio, and utilized 917 tons of quarried stone and cost approximately $1 million. Another example is the Waterfront Improvement Project in Euclid, Ohio, which cost community $21 million for 3,000 feet of shoreline stabilization and recreational services. The Earthen Made team is composed of Dr. Stephen Durek and myself. Dr. Durek holds a PhD in environmental engineering from the University of Iowa and has 25 plus years of experience in the fields of civil, environmental, and chemical engineering. Dr. Durek also founded another startup, Riverbend R3, serving as the liaison to the community for dredge sediment management planning as well as having experience producing beneficial use material. My own background is in concrete engineering with 5 years of experience in concrete mix design and material testing. I graduated from the University of Akron with a bachelor's in civil engineering, and I'm a licensed civil EIT within the state of Ohio. Earthen Made's vision is simple. We want to create green technology for a blue planet. Thank you.
Thank you, Andrew. If judges can now turn on their cameras and unmute their mics, and feel free to start asking questions.
Just a quick question or two, I guess. One is, it looks like you're saying you could use reusable materials, but I noticed concrete there. And you also mentioned something about enhancing it. So how would you add like an admixture to that to enhance the environmental benefit of the material that you're making, or to get certain qualities?
So we've actually been experimenting with a biochemically or biologically derived additive instead of a petroleum-based additive to utilize as a plasticizer to not only reduce water content and also increase compressive strength, but also to assist with the ability for the concrete to be poured into molds and for the air to be vibrated out significantly. As opposed to the material itself, our tests have been shown in our research that utilizing such materials as blast furnace slag and recycled stone do have positive impacts directly to the compressive strength of the material when utilized in specific proportions.
Thank you.
I have a question if nobody else has a question. So a large problem that we have is that it's very, very, very expensive to ship a large amount of stone. You know, some of these stones weigh a ton. You can only fit so many on a truck. So how would you plan to produce these? Would you be producing them on site? How do you get your material from point A to point B and cut down on green gas emissions that way?
Excellent question. The answer to that was we have the ability to produce the material within the proximity of the project site, as well as utilizing locally sourced material. Since we're in the Midwest, we have a large amount of stockpiled material such as recycled concrete and slag, so transportation would be minimal in getting the material to the project site.
Have you looked at, sorry, one more question. Have you looked into how the different types of materials might affect the end product, and will you be looking into how you can make sort of corrections for those variances?
Absolutely. Over the past year, we've been doing significant studies in terms of the percentage of the recycled material and various components we've been introducing, and we've closely been monitoring the relationship and the performance within those various volume substitutions.
And my apologies if I missed it, but do you have an estimated price point per meter, or I don't know how you even measure it, to be honest?
Yes, shoreline erosion control is typically measured per the linear foot, and our in-house estimations, we can produce our material approximately between $300 and $400 per linear foot in comparison to the natural limestone material being used, which is 1,000 plus per linear foot.
Thank you.
I think we have time for one more question. If not,
I'll ask it if I can.
Right.
What's the I don't know, what's the life cycle of this sucker? How long will it last in your estimation?
In my estimation, although we are in the process of conducting a long-term durability test, our research shows that initial lifespan should be nothing less than 10 years, ranging upwards of 20 or 30.
So what happens when it degrades?
Well, what happens when we lose current natural products to the storms? We simply have to replace them. The nice thing is we can replace our material a lot cheaper than replacing armor stone.
Okay.
awesome. Thank you. Thank you, Andrew.
Thank you.
And I'm going to give the judges a few minutes to get their thoughts together, and then we will get started on our next pitch. if judges could turn off their cameras and turn off their mics. Thank you. All right, next up, we have Algae Busters. And remember to turn on your camera, which I see you've done. Feel free to share your screen when you're ready and hit the present button on your presentation. And once you start, I will start my timer as well.
Okay. I'm going to share and go into presentation. Okay. Good afternoon. We are Algae Busters, and we have a shocking innovation that will help improve surface water quality and the sustainability of farms. Our team is focused on reducing the non-point source of phosphorus from agricultural runoff. It's a major driver of Lake Erie's harmful algae outbreaks in the western Lake Erie Basin. Land application of manure is an important process for farming. It provides a beneficial reuse of manure as it contains nutrients for the crops. Runoff from storage systems and from land application infiltrates our waterways. To meet Ohio's goals, farmers need to be prepared for future enforceable limits that are expected in the next 2 to 3 years. We recognize that we have to be sensitive to the economic constraints on farmers. Manure management is costly. Our solution can help optimize their manure management process. The western Lake Erie Basin covers nearly 7 million acres, and it encompasses most of Northwest Ohio, as well as portions of Northeast Indiana and Southeast Michigan. In Ohio, 20% of the total applied phosphorus comes from manure application. The sheer number of farms that produce manure in the region is huge. 20% of these farm operations are large and required to have permits to regulate how they control runoff. The other 80% are small to mid-size and are not regulated yet. Thus, it's difficult to implement solutions if there is no requirement to do so. To meet this challenge, we are going to apply a novel technology that uses electrical pulses to enhance the biological process that takes place in the existing manure lagoon or storage system. The technology provides a method that is easy to implement, cheap to operate, and provides economic benefits to the farmer. Oh, sorry. We're going to use something called pulsed electric fields, PEF. PEF has been successfully used in industry, specifically with food preservation and juice extraction. It is also used to enhance the performance of anaerobic digesters. Unlike most PEF, our technology consumes 20 times less power. Results from previous field tests indicate we are treating at a cost of less than 2/10 of a cent per gallon. Credit goes to the technology developer Decant Treatment Systems for finding a way to make PEF more economical and practical. The process is simple. A few weeks before spreading manure, the manure would be pumped through a series of treatment tubes. As the manure passes through the tubes, electrodes apply a pulse that rupture and open up the organic matter, which allows the phosphorus to settle to the bottom of the lagoon. The liquid is returned to the lagoon, and the process continues until the total volume of the lagoon is treated. After a settling period, is complete and the phosphorus is settled to the bottom, the farmer can spread the nitrogen-rich liquid layer on their field. We want to build off previous field trials and experience so we can optimize the technology for full-scale implementation. A recent study by Dr. Harold Keener of OSU suggests a strategy to reduce phosphorus runoff is to let manure settle in the lagoons for more than 90 days. Farm constraints may not allow this to happen. Based on our data, we can significantly shorten this time without increasing the burden on the farm operation. We have a unique approach that addresses both improving surface water quality and improving the economics of farming. We can reduce runoff by increasing the settling rates, reducing settling time, and then improve plant health and nutrient uptake, and reduce chemical fertilizer costs, allowing the farmer to spread more of the lagoon liquid. It's not moving. There we go. Oh, hold on, one more. All right. The major limitation to implementing any solution is the lack of financial incentive for the farmer to embrace and use technology. We believe our technology can help break that barrier because of its simplicity and low operating costs. It will take collaboration amongst the major stakeholders to do this. Ohio EPA's H2O Technology Assessment Program is an example of a way to bring solutions to the table. We are proud to be one of the 10 technologies they have selected for review this year. We are ready to move forward and build on our previous experience. Our solution is simple, flexible, scalable, and the economics make it a perfect fit for agricultural and meeting Ohio's goals. We appreciate the opportunity to participate in Erie Hack, and I would like to open it up for the questions from the panel.
Thank you, Steve. If the judges could now turn on their cameras and unmute their mics and start asking their questions.
Okay, I'll bite here. I have a question about, and I can't claim to be an expert in this, so I might need you to sort of pull me along here. So you have this, phosphorus, which is in this sort of in the organic material, and your lysing cells, or you're exploding, releasing that phosphorus. How do you prevent? And again, it's going to show my lack of understanding here in the chemical area. How do you prevent the phosphorus from partitioning into the solute phase and moving out with your water? Do you want it to? Don't you want to settle out your phosphorus? How are you going to deal with accidentally sending it through, essentially? And how can you ensure that it's being retained, I guess, is the question, in those lagoons?
I'm looking at one of my team members here. He's going to, what's that? Oh, that's right. Yeah, that's right. So the phosphorus, when we've looked at previous trials, most of the phosphorus is in the bottom layer. So the pumping is you're pumping the liquid layer off the top of that.
Okay.
And the phosphorus isn't in that layer unless you want it to be. So you can vary the treatment period or treatment time to try to gauge that, because phosphorus is a beneficial nutrient. You just don't want too much of it.
Okay. Mm-hmm.
I have a question about the stakeholders. So I had a chance to meet a bunch of local farmers, and to me, it's like this is one more thing, one more layer. So could you talk a little bit more about how you were able to, gain with anyone you have at the table to get behind this?
Well, it's right now I think H2O Ohio is probably our biggest supporter of it right now, and they're in the final stages of finishing their technology assessment. But you bring up a good point about farmers. We don't want to burden them. We don't want to add just one more thing to them. Our vision is they probably wouldn't even have to own the equipment. You apply your lagoon liquid manure a couple times a year. So why hold equipment to do that? This could be a service that would go around and treat these lagoons before they are ready to apply. So we want to make it simple.
Thank you.
You're welcome.
All right. We have time for one more question.
Has this practice been used on any in any manure ponds so far?
Yes, probably the biggest test of it was about a 600,000 gallon sludge tank that sludge was applied to farmland. So it was from a waste treatment plant.
Beneficial reuse.
But that sludge was being applied to farms. So they had to drop the phosphorus levels. And there have been trials on hog farm lagoons, and that showed a decrease in phosphorus. And also another side benefit is it removes the odors because it kills the pathogens. And but some of those trials are dated. And of course, whenever you do a trial, you always think about, oh, if we would have done that, we could have learned this. So, we want to try to get there.
Thank you, Steve, and thank you, judges, for your questions. So next up, we have a 15-minute break. Our next pitch isn't until 3 p.m. So if everyone could turn off their cameras and turn off their mics, I will see you all back here at 2:55 p.m.
Just a minute.
We're at the 2:55 mark. And if the judges could please turn off on their cameras momentarily so that I can take attendance on who is here. Okay, awesome, thank you. So now that we have all the judges back and our next presenter is ready, and judges, yes, please turn off your camera. We can go ahead and get started with Agri-Tech Ohio. So Joe James, if you are ready, you feel free to start presenting. Make sure you have your camera on, make sure you've shared your screen, which you've done, and click the present button in the bottom right corner. That works too. And
Felicia.
Our next presenter is ready. And judges, yes, please turn off your camera. Okay, cool. So whenever you're ready, I will start my timer. Already, you feel free to start presenting.
I just want to know if you can hear me.
Yes.
Okay, and I didn't see a present button, so am I okay?
You've presented, you're good.
Okay. Let me know when you're ready.
I'm ready when you are.
Good. Using our CRBBP process, we plant and then multitask very special biocrops to less expensively do good things for the health and well-being of Lake Erie, communities, and the planet. Mic on. Hi, I'm Joe James. I'm a former 33-year economic development professional. I served a 6-year term as a secretarial appointee on the Federal Biomass Research and Development Technical Advisory Committee. And I invented and patented our CRBBP process and licensed and patented an innovative biomass carbon.
Joe, I think you are on mute.
Oh my goodness. Can you hear me now?
Yes.
Yes.
Okay. So our company is focused on several local, national, and global challenges like climate change, where there's a need to extract CO2 from the atmosphere, which is causing global warming, which impacts Lake Erie. The removal of or prevention of harmful algal blooms, which require the removal of
excess phosphorus and nitrogen from watershed farm soils and other environmental challenges. Our solution is our combined remediation, biomass, and bioproduct production process. You can tell why we would like to refer to it as CRBBP instead of the full name. But again, using that, we plant and multitask very special biocrops to capture CO2 and simultaneously remediate contaminated air, soil, and water. And then we harvest the biocrops and convert the resulting biomass, which contains the captured carbon, into cost-advantaged circular economy bioproducts, which never have to end up as waste. Biomass sorghum, which is our preferred crop, grows fast and big, and in 6 months captures lots of CO2 per acre as compared to standard sorghum. Standard sorghum is on the left and biomass sorghum is shown on the right. We had an analysis done for us by the University of California at Berkeley that shows that biomass sorghum will actually capture nearly 4 times as much CO2 as an equal acreage of trees and twice as much as switchgrass, a commonly known biocrop. So we can plant biomass sorghum in farmland in the Lake Erie watershed and extract lots of nitrogen and phosphorus. We can also float biocrops in a farm blanket on Lake Erie so we can treat surface water. And we could also provide some cooling to reduce the temperature of certain of those waters where that temperature rise has caused problems. We can also create biomass sorghum spray fields into which challenged or polluted runoff and or not fully clean wastewater can be sprayed, and the crops will take care of the final cleanup of that water, get it up to standard. So again, once we perform those environmental services, we then harvest our crops and convert the resulting biomass into circular economy bioproducts. They include making a superior alternative to carbon black filler powder, which you may know is used to make plastics, composites, and by the way, tires are 30% carbon black. But carbon black is a pretty nasty material. It's got all the lead and mercury and other nasty stuff from the oil from which it's made. We can also make a superior poultry house bedding that's more absorbent and also controls ammonia better. And we can make a nutrient-rich biochar soil amendment from that litter. And we've demonstrated interest from the lawn and garden care market in using it to make potting soil. We have some outstanding collaborators, R&D partners, and funders. They're shown here. Let me point out Dominion Energy, which has a presence in Ohio, and we'll be doing some things in Ohio with them in this coming year. We've gotten funding from USDA and recently a grant from the Department of Defense Biomade program with our partner, the University of Akron School of Polymer Science, that's helping us make our fillers and our bioplastics. We certainly have competitors. They're listed here. We have some advantages over those competitors, not only in the efficacy of our process, but the multitasking features of what we do allow us to spread the cost of growing our crops over several sequential activities, including providing environmental services and then making bioproducts. This cost spreading makes the cost of each of our activities less costly than it would otherwise been had we grown the crops for a single purpose. We've accomplished several milestones, including extracting nitrogen and phosphorus from Maryland's Chesapeake Bay watershed farm soils. We've demonstrated the efficacy of our cost-advantaged bioproducts. Our Maryland operating affiliate was selected by and invested in by the Exelon Foundation's Climate Change Investment Initiative.
That is the 5-minute mark, and
Okay.
I have to call time now.
I'm ready.
Awesome, thank you. Okay, so if the judges could now turn on their videos and unmute their mics and start asking their questions.
I have a question I could start. So if you are counting on current ag landowners to plant this product, I'm curious what the price per acre is compared to, say current soybean or corn, row crop prices in Ohio.
It's comparable to those crops. The difference is that our crop just grows bigger. And we've collaborated in the past with farmers, particularly those that are up against the edge of having so much nitrogen and phosphorus that they may be impeded from continuing to use poultry litter, which is a commonly used fertilizer all across the country, but particularly in places where there's lots of poultry production.
Thank you.
Are you expecting your market to grow commensurate with the production? So if you wanted to scale this up, is the market wide enough that you can find a sink for all of the products that you're making, the biogas sorghum? You were talking about carbon black and the poultry housing and so on and so forth. Do you expect that it's large enough?
We think so, and some indication of that is the collaborations that we currently have that are relatively new with two major utilities. The Exelon Corporation is the nation's largest utility. It's got operations in several cities. We are beginning a relationship with them by planting on their sites in Baltimore. Dominion Energy is also a very substantial utility. They have gas operations in Ohio, and we are discussing with them this spring planting on one or more of their sites in Ohio, and they also have sites in West Virginia, another place in which we're going to be active. So to answer your question, those utilities have an interest in purchasing the biochar and burying that in their sites as a way of sequestering the captured carbon. So we perform a service of both capturing the CO2 and then sequestering the captured carbon in their soils. And they are working with us to generate carbon credits to support that activity.
I see, thank you.
I have a question about the floating beds. So actually putting that in a lake. So who would the likely partners be for that, and has any type of conversations been made to move forward with that idea?
Well, first of all, let me say that we are very interested in collaborating with local communities, with wastewater treatment plant operators and others that we have not yet had a chance to talk to figure out how we might collaborate. But we developed this concept of essentially a floating farm as we were looking at the terrible catastrophe that's occurring on the Salton Sea in the southernmost part of California. And so we would be glad to collaborate with universities, with wastewater treatment operators, with municipalities and others to design and then deploy this floating farm concept. But it's not new. One of the competitors that I referred to, Floating Islands International, is doing something similar. They're just not using the types of crops that we're using.
Thank you.
All right. Thank you, Joe. Now I will give the judges a minute or two to get their scores together as we also transition into our next team.
Well, thank you for the opportunity, and I look forward to hearing back on the results. Thank you.
Thank you. All right, so we are ready to start with our next team. Anabaena, if you could share your screen, turn on your video as you speak, and I will start my timer as soon as you're ready.
Okay. Okay. Sorry. My name is Darren. I'm a master's student in entrepreneurial biotechnology at Case Western Reserve University. And my project is called Anabaena. It's a project using the Azolla fern for phytoremediation of nutrients from the Lake Erie watershed. So one of the big problems contributing to the harmful algae blooms is the excessive runoff of nitrogen and phosphorus from agricultural operations around the Great Lakes. These excessive nutrients deplete the soil of organic matter, which is used to retain water and nutrients and also helps prevent erosion and eutrophication. So we're only going to use more nitrogen fertilizer as our populations continue to increase. And the poor soil health only encourages the use of more synthetic fertilizer, creating a harmful feedback loop. Organic fertilizers are a great way to kind of stop a lot of the negative effects. They don't have the same nitrogen content, making them a less attractive option for farmers. Biological options for water treatment are available, but they're energy intensive due to the need to aerate the biomass and separate it from the water. So the fern Azolla is one of the fastest growing plants on the planet. It holds a nitrogen fixing bacteria inside of its leaves that enables the rapid growth. On the top left there, that's just a diagram of the plant with the leaves, and then a picture of the plant itself. So it has a very high affinity for nitrogen and phosphorus. In fact, when it's grown in nitrogen, the bacteria switches to producing hydrogen gas instead of nitrogen, and the growth rate is still maintained. The remediation rates are dependent on a variety of factors, including temperature, pH of the water, and the amount of nutrients available as well. When the biomass is planted in the soil, the high carbon to nitrogen ratio promotes the development of organic matter in the soil. And this chart on the bottom shows the use of Azolla as a fertilizer relative to other treatments, and its success has led it to be used as a fertilizer widely in the global south, particularly in rice-producing countries like Vietnam and India. So what we would be doing was designing a vertical structure that would contain multiple levels of this Azolla growing using water that has been contaminated with excessive runoff from agricultural operations. The flat nature of its growth allows you to stack a lot of levels on top of it. And we would like to target locations that are high in runoff and close to agricultural operations. This biomass would be converted into a nutrient-rich fertilizer that's high in nitrogen and phosphorus. You can feed the biomass to worms. You can ferment it using microbes, which would also create a biogas as a byproduct, or you can just pelletize it into a form that's familiar to farmers. Construction costs are about $30 a square foot, and that is just including the lights and the structure as well. But we'd have to include estimates for water pumping equipment in addition. The next steps would be to use biotechnology to enhance the nutrient remediation and biomass production. So that just means there are genes that are responsible for uptaking these nutrients. So we would like to upregulate those to increase the rates of remediation, and then enhancing photosynthesis to increase the rate at which the plants grow and hence absorb nutrients from the water. Another key step would be developing automated biomass harvesting and water pumping systems to respond to changes in nutrient levels in the lake. So when there's high levels of runoff, then you could adjust the operations to consume more water and release it back into the lake. And then looking at ways to use the biomass. So for example, bioplastics, fertilizers, and bioenergy as well. And that's it. Any questions.
Thank you, Darren. And if the judges could now turn on their cameras, unmute their mics, and start asking their questions.
I have a question. Going back to the construction costs for this, can you kind of convert that to what it would take for an area? So if you're talking remediation, like just put that in terms of dollars of, and we believe that this can take care of, X problem.
So I think it's really location dependent. That's one thing. So I wanted it to be very modular. So if you're tackling maybe a small stream, you could have one unit there. But if you have a larger, basin or watershed, you could, deploy it in a larger vertical or horizontal fashion as well. So I think it really depends on the solution that you're trying to tackle. I wouldn't say there's one general cost structure.
Thank you.
Is Isola something that is already found in like the Lake Erie watershed basin? Because I don't know that answer.
I know it is around Ohio and the Great Lakes, but I don't know if it's a very prominent organism. It needs really still waters to grow. So the kind of turbulent nature of the lake isn't really conducive for the growth.
Maybe a quick follow-on question to that. And maybe I'm misunderstanding that. It sounds like you were talking about installing these sort of in situ in the lake, floating, or if that is the case, then you might get pushback on like bioengineered organisms. Why would you not want to have this as an isolated treatment process that you would pump into and then pump back out instead? Is it the cost?
So no, this wouldn't be on the lake. So it would be, as you described, an isolated unit, so we could control the environment. Yeah.
Okay, thank you for clarifying. I'm glad I asked.
No problem. Sorry.
We still have time for one or two more questions.
I guess I could just piggyback on Donna's question. Can you guarantee that you said that this reproduces in what you said every 2 days or something like that? Is that what I heard?
So it can double its biomass in about 2 days.
Double its biomass. So would you be able to guarantee to, keep this, within the structure that you're talking about? I guess my fear would be that it would reproduce so fast that being, not native, it could spread, and then we'd have a whole nother sort of ecological problem. Does that make sense, or is it always going to be self-contained?
That comes back to it being isolated as a unit operation, right? Like a plant almost, am I right?
Would have to bring it release back in, filter that to ensure that the biomass wouldn't escape. But like I said earlier, the kind of turbulent nature of the lake isn't really conducive to the growth of the organism, or else it most likely would have, overtaken the harmful algae that already habitate the lake.
I have one more question. So I saw that it was nitrogen fixing. What's the impact that it has on phosphorus?
So it's the organism needs phosphorus because it already fixes nitrogen. So it's has a very high affinity for phosphorus uptake as well.
Okay, thank you.
Awesome. Thank you, Darren. So we are going to take another 15-minute break, and next up will be RNA Power. And so I will see you back at 3:35.
Hello.
Hi, John. We'll be
Hi,
getting
how are you?
started in about 5 minutes.
Okay. So sleepy. Here we go.
Hi, everyone. We're going to go ahead and start up again. So if the judges could turn on their cameras for a second, just to show me that you're here. Awesome. Thank you. And feel free to turn your cameras back off. And John, you have your camera on. When you're ready, go ahead and share your screen. And when you are ready to start presenting, make sure you click the present button. And when you start presenting, I will start my timer.
Okay, unmuted now. Cool. Okay, 3, 2, 1, all that kind of stuff. We'll start now. Hey everybody, I'm John. I'm here to talk to you about RNA Power team. We're here to address some surface water issues, specifically with HABs, the really cool new RNA technology, RNA-based technology, to do some really interesting things that we think could do a lot of good for the environment there in the Great Lakes, specifically in Lake Erie. Oh, why is this not advancing? There we go, technical difficulty. So first to meet the team, I'm John. I'm a molecular biologist. My background is in early stage cancer diagnostics and biopharma. First company exited by IPO. My co-founder, Erica, is an expert in molecular ecology and bioinformatics. Gary from Veriset on the team is a kind of the premier expert in microbiome analytics these days, especially environmental microbiome analytics. And Marie-Tate Ball is our biz dev director to make sure that we actually can pull this off, because that's incredibly important for any team. So let's chat about why this is an issue. So 2014, 400,000 people in Toledo had no water. And this is not something that just happened in 2014 or that only affects Toledo. As you are likely aware, this is an issue that is going to hit much of the Western Basin, and it continues to be a problem, and it will be a problem again. So these things in general, like I think, $71 million was lost in 2011 alone in the Western Basin. That from a recent study. Canada predicts $5.3 billion spent on HABs in the next 30 years. Comes out to about $172 million a year. In general, these blooms are difficult to understand, not just where they're going, but the severity of what's going to actually happen. The risk involved, just because there's a bloom doesn't mean it's going to be another Toledo. But if it is, you need to be prepared for it. And there are technologies out there for early stage intervention. Back when I did cancer research, we used to always say, early intervention or early detection is cure. And that's kind of what we're moving towards here. So what do we do now? So currently there's all this great satellite imagery and fluorescent probe data to give you an idea of where these blooms are going to go. They don't tell you kind of how bad they're going to be. And on the back end, we have a lot of really cool technology to determine the proteins that have been released, the toxins, right? So you can do ELISA, mass spec, but these are after the fact. So this bit in the middle, we're just not addressing, right? So this is where we step in. So ECO is a company that does aquatic biotechnology. We have a couple of systems to be able to filter a large volume of water and preserve any of the nucleic acid information in there. This allows us to actually preserve RNA, and that kind of changes the game. DNA sticks around the environment forever. It doesn't tell you that much, but RNA tells you what's actually alive, what toxins are being produced, and what's actually going on within the community. On top of that, we've partnered with Veriset, who has a really cool device called the PhyloChip, which allows you to do whole microbiome analysis. And this is like a way to look at the whole neighborhood. Who's up, who's down, who's playing, who's around each other. This is the data that we're missing. With this data, coupled with the data that we already have, we can fill that gap. And what that means is that we can predict not just where they're going with the data that we're already collecting, but how severe it's going to be before it's severe, especially when we back calculate with the data that we're getting from the back end. It takes an army. We need all of this data to really be able to prevent and mitigate this problem so we don't have another Toledo in another area. We already have great connections with the U.S. Coast Guard and Los Angeles Department of Water and Power, Naval Research Labs, on some of the other similarly closely related biosecurity issues that we're working with them. These are not grants, these are contracts. We are commercialized. And in addition, we're members of the Cleveland Water Alliance, and NOAA has already released $10,000 of rapid funds for this project because they believe in it. You can read the quote there. I think the most important thing about this is saying, I look forward to the results from these, and they may assist us in enhancing our understanding of cyanobacteria bloom ecology. That's what we're trying to do. That allows us to actually solve this problem. So in summary, we're enhancing our understanding of cyanobacteria bloom ecology. That's the goal here. And this allows us to actually intervene in in a pinch, when we need to actually intervene. We can determine where the blooms are, whether the blooms are toxic or not, how toxic they're going to be. And we can create a forecasting model to predict not only the location, but the severity of the blooms. And that's key to preventing issues like we saw in the past. And we hope that you'll join us in helping support this project. We've already been validated by a number of great organizations, and we're happy to take any questions and tell you about how we can achieve what we're setting out to do.
And judges, whenever you're ready, feel free to start asking questions.
I'll ask a question. John, how long does it take for you to get the results? So, I mean, it's pretty awesome that you could, predict toxicity and size and such. From the time you take the sample, how long before you have an idea?
Yeah, that's a good point of clarity, the clarification that we should make here. So once we receive in lab, we can get results from our, so what we do at ECO is we're going to tell you how much toxin is being produced and what type of toxin is being produced. That allows us to give risk. So once we get that in-house, that'll be 2 to 3 days. Then we send it over to Veriset for the whole microbiome thing. What we're doing here is collecting a data set, right? So that we can use all the ancillary data to figure out how to build that forecasting model. But we need to build up the data set before we can actually do that. As far as turnaround time, we're looking at 2 to 3 days on our end, additional time on Veriset's end because we do all the extraction and preservation of the RNA DNA. And then this allows us to build a data set that we use additional data points to create the forecasting model.
So how much time does Veriset need? I mean, you said 2 or 3 days for you, but if that's only one piece of the puzzle, how much for the whole thing? From take a sample to be able to give the results to, decision makers, along the way. Yeah, the goal is for once Veriset receives it to have data within a week. But that is something that, we validated our procedure, but I can't speak to theirs confidently without them. I don't want to give you it's going to be X number of days or X number of hours or X number of man hours because we validated our process. Their process is still in discovery. It's out of Lawrence Berkeley lab. So it's kind of they're well validated as far as their results. But as far as a commercial entity is getting a turnaround time, that's like something I can just promise you. I can't give you a direct guarantee. At this point, what we're seeking to do here is take a year's worth of data to be able to build the forecasting model that will be able to do proper predictions.
I would add, I think that's a great question. Veriset can be as fast as a week. Because they're still a small company, they're consolidating samples and they can go as fast as needed with additional feeds. So the key thing is that it's the microbiome analysis that is new data that, for instance, the US Coast Guard is interested in, which is a general understanding to be able to then give more details. The forecasting model is really the key.
Thank you.
All right, we have time for one more question.
So I know at the sewer district we have and we modify our own forecasting model for bacteria for sampling at the beaches. So as a public agency, we've done that. You guys are not a public agency, you're looking to do that. Would you say that the major hurdle is financial right now, or is it data, or is it technology?
I don't think that's quite, what we're doing here is a little bit different than anybody's done previously. This is not something that public agencies have done effectively in the past. I understand that there's forecasting models that are updated pretty significantly as far as where blooms are going to be and things like that. But the risk is, the level of toxin production is the issue. And once the data set is there, then the cost is very low. Production of that data set, this project is not incredibly expensive either. But the main missing piece, according to the Ohio State University report that just came out this year, was what we listed on that last slide, was the ability to accurately predict and forecast severity. And that has to do with toxin production, as well as, looking at phage in the water and things like that. Because basically, these things will produce a lot of toxin, but unless they're lysed, unless they break open, you don't have toxin in the water. So the severity of the bloom is somewhat variable, and that we need to understand the underlying conditions of why that bloom becomes toxic and how it becomes toxic to be able to do a forecasting model that's actually allows you to mitigate effectively.
Yeah, I would just add that the 10K we just got from rapid funds from NOAA is exactly to start getting data on the genetic markers of this year's bloom. WEtech was able, thanks to Cleveland Water Alliance, we were able to capture pre and post bloom samples in Cleveland and Toledo. And we just got 10K from NOAA to be able to analyze that. The exciting technology also is that you capture a genetic snapshot of RNA that can be analyzed in the future. So basically you've got that bank of data, and that's why we're working. Actually, we are just signing a Great Lakes Protection Fund proposal, and we have the Detroit water plant, the Toledo water plant, and Cleveland water plant interested from WEtech to get the genetic markers information. So it's not rapid detection. It's really, as John explained, it's really early on, and it's just breakthrough data. RNA was not available in the past at that level. Now it is.
Yeah, RNA is not sitting outside of our company that is collected in the environment.
Okay, thank you. And I will give the judges a few minutes to get their thoughts and scores together. But if we could queue up the next team, I love Lake Erie. If you want to go ahead and have your camera on and share your screen and start presenting so that we can see the first slide of your presentation. Okay, and whenever you're ready, you can go ahead and get started, and I will have my timer start whenever you start.
Thank you. The name of our team reflects the vision of our team members as well as the passion of our team members, and it also reflects the customers we're trying to approach with the product. The goal is to provide smart information, not just big data. And this is in response to the Community Water Resources Challenge. So the key things is, how do we protect, nurture, and sustain Lake Erie? Getting better information to the communities, increase, just like we have annual physicals. What do we know about the lake, and how is the health changing? And also start looking at the correlations between a variety of factors in the lake, and then the outputs from that. And then use all this data to support decision making at multiple levels. The system architecture is simply then bringing imagery and time series data sets. On the left side, you see a variety of new and existing imagery data sets, and the bottom, the 4 ones that we access. So bring them together, provision and manage new ones, provide a unified access, and a very user-friendly website for multiple levels of users. And then look at the time series as well as look at the satellite imagery in that context. So for example, although this is kind of the proposed interface, how it might look like, but this is not in the current delivered. But on the left, you can see NOAA is already delivering some imagery related to the big Lake Erie and the Bloom. And there's another site that also provides that. And then you can have very powerful time series data that can be, merged together at the same time. There's a related portal for HAPS, for example, but that shows more of the satellite imagery, not necessarily showing the blooms. And then you can click on it, and the bottom, the time series, in this case, data wasn't available, possibly because it didn't load, but similar concept exists. And then the other thing is we want to go basin wide, not just the lake. We want to make sure that we get the watershed and then see what's happening in the watershed, and also look at the blooms and the health of the lake at the same time. On the left is my Copernicus account, in which I explored trying to get satellite data for the basin, and that's moved forward quite well. On the right side is where we explored the existing GLDW data warehouse and connecting to that programmatically to get that data into our application. The application of artificial intelligence to get a variety of things from imagery is really exploding. This is the latest issue of the remote sensing issue. And then there are things in there like detecting water currents and whatever things. And there's an article from the inside there that talks about the big EarthNet that's coming up in Germany, which can discuss and define and discover a bunch of things related to the land, what kind of agriculture is going on. And then as we talked to Kevin, they also had just received a grant for Maumee Watershed. They're starting to look at satellite imagery to explore that. So it's a validation that exploration of data is a good thing. So the stakeholders are clearly the people, getting them information to help. We also talked to a variety of people, mentors, and that was very helpful. And then, for example, Aaron from Sandusky said lakeshore erosion as well as ice formation would be of interest. And Kevin, we already discussed and how we might collaborate with him. And so the progress is we got several data access things already sorted out. The system architecture is defined. We got some sample data, put together sample UI, define the cloud access to the multiple cloud partners, and some additional data access is in progress. And we got some new IoT hardware to look at how we might get some fresh IoT data into the infrastructure. The team, I lead the team, and Steve's also on the call here. Adam's picture is up here, and he went to Lake Erie to kind of say hello to us. There was last weekend, but there was a lot of wind, and so unfortunately we can't hear him. And then Jake and Devin. So that's it. Any questions?
Thank you. And judges, feel free to get started whenever you're ready.
Hi, Sudhir. Ruben here.
Hey, Ruben.
How are you looking to commercialize this, or is this intended to be like a public resource, for the community to use, like a data warehouse or a clearinghouse? Just a little curious.
So the big Microsoft and Google are getting into Earth, luckily for us now. And so it's possible that they would pick some of the pieces from it and include that as part of their next Earth Explorer, and which would be a good thing, because really not necessarily for the big money, so to speak. We want to, and we can even open source. Since we are building on open source, our goal would be to open source as much of it as possible, have a relationship with the researcher. Because right now, going from the satellite to the image and EPD format and LiDAR, it's a researcher's, grad students kind of exercise. And to me, it shouldn't be like that. So improving the data access, improving the end products, trying to create a visual thing for doing the, and then, then whoever wants to build it, open source it, include as part of the product. That's the vision. But to me, I think we haven't gone to the communities yet saying, how would you like to see the correlation from this thing? So because there are multiple levels. Then the decision maker, Aaron, how would you like to see it? And the researchers like Kevin, how would you want the data? So there are multiple users, and there might be therefore different go-to-market strategies based on each one. But the whole goal behind is to be actually a much more open source in the end, rather than creating a large product.
Okay, thanks.
I can go. Updating data is often the hardest part, especially when you have multiple data sources in one location, or data sources from multiple agencies in one location. How would you hope that that data could be updated over time?
So I think the most important in data management is having a good data backend that can absorb your data without falling apart. And then the best place for that is actually in cloud, given that you have Amazon buckets or Google blobs that serve as Netflix images. And then the time series databases that have come along, the one called Timescale, so that you can run time series data. So having a good backend is, we got that. But the second thing is having pipelines that feed it automatically, that cleanse, and which already exists. They just need to be brought together and then provisioned. So the infrastructure is there, and then quality assurance and things like that, that all gets built into the pipeline. And so therefore it automatically updates and brings it together without any manual intervention. That's the vision.
All right, we have time for one more question.
Is your hope that there would be analytical tools that could be run alongside this cloud data source?
We are running some analytical tools, AI tools ourselves, some of our previous projects that we have done, applying those AI tools. In fact, the issue that I showed you, half of the articles are actually applying the AI-based tools to this data. And then luckily can be very easily integrated, because fortunately for us, Google and others have thrown all their AI tools in the cloud. So therefore application of that, it's actually the domain knowledge and bringing that thing carefully. That's more the difficulty now versus the availability of the tools. But we have been successful in extracting things like building footprints from cloud data. And so we just want to expand that further to, can we see a particular type of crop, phosphorus or nitrogen, or, algal bloom is well addressed, but the new satellite data also, there's opportunity for you to go detect perhaps a new cyanobacterial index that improves upon the previous work. So there's a bit of a research in some of it, as well as actually delivering something that the community gets excited about, saying, oh, I don't know that had happened, apart from just numbers and things. Seeing a picture evolve that gives you a sense for, oh, we had a bad lake in 60s and it's not much better now, we're going this way. If you love the lake, what can we do for it? Therefore getting the community excited. I think that's one of the key things in the whole picture.
Thank you.
Thank you.
Thank you. I love Lake Erie. We have one more team, and not all of the team members are here, so we're going to take one more break. If everyone could be back in 7 minutes at 4:05, and then we'll get started with the last team. All right, as our last team is getting ready to start presenting, if judges could turn on their camera, show me that you're ready. Okay, thank you. Awesome. Now we have our next team, last but not least, is farm filtration integration. And I see that you have your camera on. When you're ready, share your screen and hit the present button on your PowerPoint. Thank you. And whenever you start, I will start my timer.
Hi, my name is Priscilla. I'm a fashion design major in Kent State University.
My name is Ethan Broden. I am a architecture grad student at Kent State University.
I'm Agri-Tech Ohio, and I'm biotech major junior in Kent State.
And I'm Justin Allen, and I'm in architectural study here at Kent State University. And this is our project, Farm Filtration Integration. Farm filtration integration is a plan to collect farm runoff to benefit the farmers and community around Lake Erie. Once the runoff is collected, farmers can then use it to grow algae collected from Lake Erie. Next, they can then process this algae for themselves or their personal use to become biofuel, and this will better the community and the farmers as a whole.
The challenges that we are taking for our project is the water surface quality. With less water farm runoff in lake algae, the algae will have less nutrients to grow, and over time, the growth of algae will become less. In turn, it will make a better environment for the marine ecosystem and reduce the amount of dead zones. This will also make the water cleaner and fresher water. So next, we are also tackling water and infrastructure, wastewater infrastructure. This will build a better farm irrigation, controlling and maintaining farm runoff so it doesn't reach the lake. Then that extra runoff can be used to cultivate algae, which will be used to make the fuel. So this makes overall the lake cleaner in the long run.
Beyond Lake Erie is the idea that we can be taken to bigger and broader lengths. So with so many farms around the world, it's possible for them to grow out of fuel sources, even just looking at it as another crop, for it to be profitable for them and give them incentive. With algae being sort of a replacement as that modern fuel, it'll be a cleaner and more healthy environment. It can also be used to transform the fuel industry in a more economic way, and use those existing sciences and technologies to build up our idea and make it more reality. With such big ideas, we should start out somewhere with a lot of to do. So at our university, we have a lot of resources to help with that, using different kinds of labs, such as fabrication labs or even science labs in the university space. We also have a diverse group with lots of expertise in different areas. Our professors are also here with many different expertise of their own. And funding with the university will help us prototype and print and whatever we need to do to help our idea become a reality.
With all that being said, this idea can bring many good things to the community of Lake Erie. Farmers would benefit from this. They can now go on and grow a new crop on their land and get clean fuel from it, and they can do with whatever they choose. This can make them a profit or save them money by not having to pay for other fuels. The people living around Lake Erie in time will be able to look at a more cleaner water surface, Lake Erie, with time even having the lake water to be cleaner itself. We thank you for listening for our presentation, and I hope, and we hope you enjoyed. If there's any question you have, please let us know.
And judges, you can start asking questions whenever you're ready.
I suppose my first question, I'll be quick, Ruth. How exactly do you plan to collect the algae off of Lake Erie?
So far, we have planned to create like a netting system that would then be able to collect it off, like skimming the lake surface, to ensure we do not like collect any unwanted marine life, such as any aquatic fish that might be in the area, or any other unwanted materials, so it stays as close to just being the algae itself. So that's so far my plan to do that.
Have you looked into what if it would be net neutral or in terms of the production of fuel from the algae, the processes that would be used to do that, and also how the fuel would be used, like how clean would it have to be, or where would it be used, farm equipment or something else, do you have any information on any specs on that, any research?
We have researched like different uses for this biofuel. We haven't researched exactly how clean it has to be used in specific items. So far, it's been shown that it can be used fairly easily just as a diesel. So we thought that then it could just be used in regular diesel engines, then so the farmer could use it for their own personal use. Or if they choose to save it up, they could also just sell it themselves as a fuel.
We have time for one or two more questions. Well, if there are no more questions, I just want to thank everyone for their incredible pitches and for your hard work this Erie Hack. The judges will now head off to the deliberation room, and judges on this Zoom room, please be sure to turn off your camera and make sure that your mics are on mute. And thank you, Justin, for your pitch. So judges, please go ahead and head to the other room, the Google Meet that I had sent you all earlier. Thank you.
Appreciate it.
So just
Hi, everyone, and thank you all for your patience. That was not an easy deliberation. The judges are making their way back to us, and while they're doing that, I'd like to reintroduce Brian Stubbs to announce which teams will be advancing to the semifinals. So take it away, Brian.
Thank you, Felicia, and a big thank you to all of our participating teams. Whether you'll be moving on to the next round or not, on behalf of all of us, we strongly encourage you to continue pursuing your innovative and entrepreneurial journeys. We look forward to following along with you, and regardless of what happens today, you know, we always work and continue to work with you know, innovators as they go down this journey of entrepreneurial life. So keep that in mind. So I'm excited to share that we actually have 4 teams that will move on to our regional semifinals on November 4th. So are we ready here? I'm guessing we are. And the 4 teams are Team RNA Power with their innovative contaminated water treatment, Agri-Tech Ohio with Joe's combined remediation biomass and bioproduct production process. Number 3, and these are in no order, this is just a 4 moving on, is Team Island Hoppers and their plantable boat bumper islands for native aquatic plants. And the 4th team moving on is Team Algae Busters and their process for accelerating the biological process in manure lagoons. So winning teams will have the opportunity to continue competing and earning prize dollars and support services. Congratulations to our winning teams and to everyone who participated today. No matter the outcome, we're happy to share our resources and help you further your impact. Please don't hesitate to reach out to our team at the Cleveland Water Alliance if we can support you. Winning teams, Felicia will be reaching out directly to coordinate next steps, and we're looking forward to seeing you at the semifinals on November 4th. So again, congratulations, and now I'm going to turn it back over to Felicia to close us out. Felicia?
Thank you, Brian. And thank you again to all Erie Hack participants for your hard work. And thank you, judges, for volunteering your time to hear all of these creative pitches. As Brian mentioned, I will be reaching out with next steps and more information. And we want to invite you all to tune into our next quarterfinal this Tuesday at 1 p.m., which will be hosted by Blackstone LaunchPad at the University at Buffalo. Thank you and enjoy your evenings.